Hey everyone, my name is Nick Patrick. I'm the co-founder and CEO of Radar, and today we're going to build a store locator on iOS using Radar's iOS SDK, geofence search API, and forward geocoding API. I'm sure you all have used a restaurant app or a shopping app that has a store locator feature. Oftentimes there's a text box where you can search for an address. Maybe it defaults to your current location. It retrieves nearby stores and it shows them either on a map or in a table. So we're going to build one of those today. First things first, we need to sign up for Radar. You can sign up for Radar for free and create up to 1,000 geofences and make 100,000 API requests per month for free. Once we've signed up for Radar, we can toggle over to the geofences page. And Radar is a very powerful location tracking and geofencing platform. We can also use the geofences that we've imported to search them and show them on a map for use cases like store locators. Multiple ways to create geofences. I can click on New here and draw them. In this particular case, I have a CSV prepared, and I'm just going to go ahead and import those geofences. The CSV will have 8 columns. It's going to have a description, which is the display name of the geofence. It's going to have a tag, which is sort of like a group ID for the geofence. I could have different groups of geofences with different tags. In this case, we'll set tag to store, an ID for the geofence, which will correspond to the store ID, a geometry for the geofence, which in this case, we'll just use a circle geometry with a 100-meter radius because that lets us specify a center point, which is going to be the map pin that we're going to show in the store locator. True to make sure the geofence is enabled. And then we can also pass some custom metadata. In this case, we're passing parking equals true or false. We could also pass drive-through equals true or false. And to search geofences, we're going to pass in the tag that we're looking for. We're going to pass in the radius and lat long to search around. And we can also pass in metadata if we want to filter down just to a specific subset of geofences. So let's go ahead and import those geofences. We can refresh the page and you can see that they show up in the dashboard. So a really easy way to manage your geofence data, your points of interest data, and use them for geofencing, but also use them for geofence search. And we can click on an individual geofence here and see tag equals store, ID equals the store ID, and parking equals true in the metadata that we've passed in. Great, so we've imported geofences corresponding to stores. Our next step is to actually create an iOS app. So we're going to create an app from scratch here. Obviously, you can also add this to an existing app. So if you have an existing app, you can skip this step. But we're just going to go ahead and create a single view app. We're going to call it store locator. We're going to use Swift in this case, and this all looks good. So we'll save that here. And now we need to install the Radar SDK. In your app, if you're using CocoaPods or Carthage, you can install the Radar SDK using CocoaPods. It's a great way to pull the SDK in and keep it up to date. You can also just install the SDK manually. So I'll go to the GitHub repo for the SDK, download the framework zipped. I can go back into the Xcode project, unzip that framework, and just drag that into the project. And you can see the Radar SDK is linked. To make sure we installed it properly, we can go and import the Radar SDK here. And we're going to initialize the SDK with our API key that we got when we signed up by calling radar.initialize with publishable key. And we can go grab that out of the dashboard. Let's go back into the dashboard. We'll go to the Get Starting page and grab this API key here. We're going to use the publishable key, which is intended to be used in client-side code. And because we imported our geofences into the test environment, we're going to use the test publishable key. I could use my live publishable key for a production app. And we will paste that in here. Let's make sure this compiles. We're good to go. Now we want to build the store locator UI. So let's go into the storyboard. And our UI is going to have 2 components. First of all, we're going to have a search bar, which is going to let the user search for an address, and a map view. So we're going to display the stores nearby that address as pins on the map. I could add other components like a loading indicator, autocomplete for the address search. I could display the stores in a table instead of on a map, but this is one way to do it that we're going to do today. So let's go ahead and add a search bar component. We'll drag that in, and we will position the search bar at the top of the window. That's fine. And then let's go and add a map view. We'll drag that in as well. And we can make it take up the full width of the window. Let's connect these to our view controller. So because we're using a map view, we need to import mapkit here. And then we need to add outlets for the components. So let's create an IB outlet for the search bar. And let's create an IB outlet for the map. And let's also make our view controller a UI search bar delegate so we can listen for the user typing text into the search bar or tapping the search button. And now we can go back into our storyboard and hook this up. So we'll go to our view controller here, and we will connect the view controller to the search bar outlet and to the map outlet, and then we'll connect the search bar to the view controller as the delegate. Let's make sure this UI loads. While we're waiting for the simulator to boot up, the next step is going to be to actually hook up these components to the Radar APIs. So when the user types text into the search box, we're going to want to take that text, which should be an address, and call the Radar geocoding API to turn that address into a lat long. And then we are going to pass that through to the geofence search API. There we go. So we've got a search box and we've got a map. And this is fine for now. All right, cool. So we've got the components there. We can always make this look prettier later. So first thing we want to do is call the geocode API when the user searches in the search bar. So we've made our view controller the search bar delegate. We're going to look for the search bar search button clicked event. We're going to make sure that we have some text here. If not, we can just return. And we're going to pass this to the Radar geocoding API. Let's import the Radar SDK first. Because we've initialized the Radar SDK in the app delegate, we don't need to reinitialize it here. It's initialized globally for use throughout the app. So radar.geocode, we are going to pass in the address. And then there's a callback here, which returns a status and then a list of addresses. So we want to make sure that we actually have some addresses here. So we'll grab the coordinate from the first address. And we could add more error handling here. For example, we could check to see if status is equal to radar status success. We'll go ahead and skip that here. And let's update the map. So we'll go, as with any sort of UI changes, we want to dispatch these on the main thread. And let's construct a MK coordinate region, which is what you use to basically control what the map is pointed at. We'll pass in the address coordinate for the center. Let's show 10 kilometers around that point. And let's set the region of the map. And sure, we'll animate it. Why not? So just to recap what we've done here, in our view controller, we've hooked up the map in the search bar. When the search bar button is clicked, we are going to grab the text and call the Radar geocoding API. That's going to give us an address with a lat long, and we're going to center the map on that lat long. Let's give it a shot. So we wait for this to boot up, and just to test this out, let's type in 20 J Street, Brooklyn, and we'll hit enter, and there we go. So we've turned this address into a lat long using Radar's geocoding API, and we've then zoomed in the map here. Great. So now that we have this coordinate, let's actually go and retrieve stores or geofences near that coordinate. So we'll turn this into a CL location object with the latitude and the longitude grabbed from the coordinate. Great. And now we can call the radar.search geofences API. And we're going to pass in the coordinate for the address. So we'll pass in near. Let's use 10,000 meters or 10 kilometers again, just for consistency. we will retrieve geofences with tag equals store. You can also filter based on metadata, so I could return just stores that have parking or not parking using the metadata that we stored on the geofences. We'll skip that here, and then a limit of 10 geofences. And this returns a callback with the status, the location, and then a list of geofences. And now in here, what we want to do is basically, let's make sure again that we have geofences. If not, we'll return. And again, we could add a loading indicator or error handling here, but we'll skip that just to speed things up. Then let's basically turn these geofences into annotations that we can add to the map. So we'll do annotations equal geofences. And we want to basically map each geofence to an annotation. So each geofence gets mapped to an annotation. And for the annotation, let's use the MK point annotation. And let's grab the geometry out of the geofence. And we know we created circle geofences, so we're going to cast this to circle geometry. You can also store polygons and polygon geofences inside of Radar. But here we're just going to grab circle. Let's set the coordinate of the annotation to the center of the geofence. And let's set the title of the annotation to the description that we stored on the geofence. And we'll grab the radar description, which has an underscore in front of it, and return the annotation. And last thing we need to do is update the map. So let's, again, on the main thread here, add the annotations to the map. And that should be it. Let's give it a try. Oops. Annotation.title. Cool. So let's boot it up and let's search for an address. We'll hit enter. And there we go. We've plotted the geofences on the map. I can zoom in to see all of them. And that's it. Again, we could make this much more sophisticated. We could use Radar's autocomplete API to autocomplete addresses as you type. We could display these on a table or a list view instead of a map. We could add error handling, of course. But hopefully this illustrates a really simple way to build a store locator by importing geofences into Radar, using our geocoding APIs, and using our geofence search APIs. And again, these same geofences that I've used to create the store locator, I can also use to power all sorts of location tracking and geofencing use cases. For example, location-based messaging when I'm nearby a store, or changing the home screen of the app to be different if I'm in store versus not in store. So we're really just scratching the surface here. That's it. Thanks everybody for tuning in, and looking forward to seeing what you'll build with Radar.